Hey guys, so today we are doing lesson 6.2, which is area of parallelograms and more triangles. So we did some triangles in 6.1, but here are some more, which we're just going to be looking at in a different way. Area of rectangles. So the area of an object is how many squares it would take to cover the inside of an object, and area is always measured in square units. So obviously when you're doing like meters, you have to say meters squared when you're talking about area. So for this one, we have the width is 3 inches, the length is 9. For the rectangle, you can calculate the area by doing the length times the width. So this one would be 27 inches squared. Area of parallelogram, so we have a rectangle. Of a rectangle, the area is length times width. If we were to take our rectangle and cut off a piece and then add it to the other side, we would have a parallelogram where two sides are parallel to each other and then the other two sides are parallel to each other. The area of a parallelogram is the same as a rectangle, so it would be length times width, but for parallelograms we usually do base times height, which this one would still be 28 centimeters. So it would look like this. For a parallelogram, we use the terms base and height. The height is measured straight up and down. So like you get measured or you measure your height, that would be the height of a parallelogram. The base and the height form a right triangle. So there should always be a 90-degree angle here for the most part. The height of this parallelogram is not 5 centimeters because it does not form a 90-degree angle with the base. So for this parallelogram, we would do 4 times 7, which would be 28 centimeters squared. Again, multiplying base times height. So area of a rectangle, you guys already know that is base times height. Area of a parallelogram is also base times height. And then our height and our base are perpendicular to each other, so they form a 90-degree angle. Altitude is another word for height. It just means that it is the height and it must be perpendicular to the base. So it has to form a 90-degree angle with the base. Sometimes we have to extend our base out to get that altitude or that height, but it's always going to be a 90-degree angle with the base. Area of triangles, so we're looking at this triangle here, okay? If I were to cut our parallelogram in half from like one corner to another, it would form two exactly the same triangles. So half the area is in each of those triangles, which basically means that the base and the height of the new triangle are the same as the parallelogram, but we are taking half of that parallelogram. So we need to either divide it by 2 or multiply the base and the height by a half. Here's the equations for area of a triangle. You guys should already know this from 6.1, but we also added in this here. You can use that instead if you'd like. I'm going to use the 1/2 base times height because that's how I was taught and that has been ingrained into my head. So if you guys want to use the base times height over 2, that's fine too. Again, remember that the height must be perpendicular to the base, so it has to form a 90-degree angle. These are how we can look at heights of triangles. So you would want to draw these on your notes. The height of a triangle can be found on the inside of the triangle. So like inside the triangle here, this one would be an acute triangle where we find it on the inside. On the outside would be a right triangle, and notice how we have our 90-degree angle here. You could have height here, or you could have base there. You could have base here, or you could have height here. It doesn't matter because when you're multiplying, it does not matter the order that you put it in. It could also be on the triangle. So on the triangle just basically means like we are going to have to extend that triangle outwards in order to create the height. Because if I were to draw it like right here, this height would not match or would not be the height of this entire triangle, because the triangle extends all the way up to here. So we need to get the height of the entire triangle there. Make sure you get that on your notes. Okay, well, I'm re-recording the slide because I messed up. So the height is always perpendicular with the base. So we have our 4 inches for the height and 5 inches for the base. Base times height, so I get 20 inches squared. For number 2, this is a parallelogram. The 3.5, we extended out the base here to create a height. So my height is 3.5, the base is 2. So I'm going to do 2 times 3.5, which is 7 centimeters squared. Again, make sure you have the centimeters squared there, or the units squared. Number 3, I didn't draw in a 90-degree angle here. I should have, but we're not going to use this length over here because 3.2 is my height, 5.1 is my base. So we're going to multiply those two together, and we get 16.32 centimeters squared. For number 4, a lot of kids were getting confused because they're like, oh, this one's not the base, but actually it is the same length as down here because parallelograms have 2 parallel sides that are congruent and the other 2 parallel sides are congruent. So my base is 11.2 and my height is 5.2. If I multiply those two together, I get 58.24 centimeters squared. For number 5, now we're moving on to triangles, so we need to change up our formula. We have 1/2 base times height, and I would just do 0.5 times 9 times 8 in my calculator, and I get 36 inches squared. For number 6, so this is a right triangle, so we are not going to use the hypotenuse. 5 is our height, 12 is our base, or vice versa. It doesn't matter. It depends on how the triangle is laying. But I'm going to do 1/2 base times height, 12 times 5 times 0.5, and I get 30 units squared. I use units squared here because they don't put the units down. So you need to use some kind of unit there. If you just put 30, I'm not going to be a huge stickler, but get into the habit because if you do go on to higher math, you're going to have to use units squared or just units or units cubed if there's nothing labeled. For number 7, our height is 17, our base is 10, so we're going to have 1/2 times 10 times 17. You multiply all those together and you get 85 centimeters squared. Then for number 8, this is another obtuse triangle. So our height is 4, our base is 7, so 1/2 of 7 times 4 would be 14 centimeters squared. And again, if I'm going too fast for you or if you need to take a break or slow down, just pause it and write down what I have. Okay, so these ones are different than the ones that we just did. For both of these, we are missing the height. We don't have a value here, we don't have a value here. So we need to find that value. So our goal is to find the height first. And we know that's the height because it makes a 90-degree angle with the base. Now, if you think back to last semester, or not last semester, but even last quarter, the Pythagorean theorem. We can easily use the Pythagorean theorem here to help us find out what the height is. So, it's a squared plus b squared equals c squared. So I'm actually just going to call this h for both of these. So we're going to do h squared plus b squared equals c squared. Now, you can put this in your calculator and do like 5 squared is 25, 3 squared is 9, or you could just subtract 3 squared from both sides and put it in your calculator exactly like this. Don't do 5 minus 3 and then square it. You need to do 5 squared minus 3 squared in your calculator. you end up getting h squared is 16, and then to get h by itself, we need to take the square root of both sides, which is 4. So h is 4. Now we need to think about our base here. So if my height is 4, my base, I have this 7 here and a 3. The entire triangle is the whole entire base. So my base would be 7 plus 3, which would be 10. So to get the area for this triangle, I'm going to do 1/2 base times height, and I end up getting 20 units squared. Because again, there's no specific units there, so I need to make sure that I write down units squared there. For number 2, again, I'm going to need to use the Pythagorean theorem. So I'm going to find h squared. My b squared is 8. And my c is 17. So again, just subtract 8 squared from both sides. Put this whole thing in your calculator. Don't do 17 minus 8 and then square it. So h squared would be 225. Then I take the square root of both sides, so I get h equals 15. And now that I have that, I can easily find the area of this parallelogram. 21 times 15 is 315 feet squared for my answer. So I'd like you guys to try the next 2. So pause it and then wait. Yes, you might have some nasty decimals and stuff in questions like these, but make sure to wait to round until the end. So for number 3, I'm going to find h. So h squared plus 7 squared equals 9 squared. Subtract that 7 squared from both sides, and again, put this whole thing in your calculator. So when you do it, you get h squared equals 32. Now, 32 is not a nice number when you just take the square root of it. So here is a trick for you. When you take the square root, h would just be the square root of 32. So we are going to put the square root of 32 in for h. And your calculator can do all this work for you, so if you use the square root, it's perfectly fine and it's a more exact answer. So for area of a triangle, I'm going to do 1/2. My base here is 7 plus 7, which is 14. So 1/2 base of 14 times height, which is the square root of 32. Type it exactly into your calculator like that. And then you get 39.5979. So I'm just going to round. And no matter what, if I do to 1 decimal place or 2, this 9 and this 7 would make this whole number round up to 6. So my answer is 39.6 units squared. Then for number 4, so same thing. We need to find h. So h squared plus 3 squared equals 5 squared. Subtract the 3 squared from both sides, and again, put this whole thing in your calculator, and you get 16. If I take the square root of both sides, I get h equals 4. Then I need to look at my base here. So my base is 3 and 8. So my base is actually 11. So the area of the parallelogram would be base 11 times height, which is 44. Which is 4, which gives you 44 units squared as your answer. Okay, so finding the part of a missing figure, finding a missing part of a figure. So the height of a triangle is 6.7 centimeters and the area is 47.57 centimeters. Find the length of the base. So area of a triangle is 1/2 base times height. So we are going to take the values that they gave us. 47.57 is my area. My height is what I'm trying to find, my base is what I'm trying to find. My height is 6.7. So I need to take my 1/2 and my 6.7 and multiply those together so that I get one constant with the b. So if I do that, I get 3.35b. And then to get b by itself, I need to divide both sides by 3.35. And you end up getting b equals 14.2 centimeters. For number 2, your area they give you, area of a parallelogram is base times height. We are trying to find the height. So my area is 48, my base is 12, and my height is h. So divide both sides by 12, and you get the h is 4 units. Okay, we did these with 6.1, so we are going to just practice them a little bit more. For the first one, so if I need to find the area of this, obviously I need to do some creating of new figures here because I can't find the area of a figure that looks like that. So I'm going to split it up into a rectangle and another rectangle, area 1 and area 2. So if this side here is 4, that means this side here would be 4. If this is 2 here and the whole thing is 6, that means this would also be 4. If this is 3, this side would be 3, and if this is 4 here, this side would also be 4. So to find the area of the first figure, I'm just going to do 6 times 4. It is a rectangle. So you get 24. And then area of the second one would be 4 times 3. So you'd have 12. And then to find the whole area, I'm going to add the first area plus the second area together. And I end up getting 36 centimeters squared. Again, you don't need to put the units on until the final answer if you want to save yourself some time. For number 2, so this is actually called a trapezoid. We're going to learn how to find the area of this in a little bit or in a couple lessons. So I am going to draw a line here so that I have a rectangle slash square and that I have a triangle. So I know that this side here is 20, which would make this side here 20. This side is 10, which would make this side 10. And because this whole entire thing is 15, this would be 5 here. Now, I don't really need to know what the hypotenuse of this triangle is because this is a right triangle and I could easily find the area of it by just doing 1/2 base times height. So the area of the triangle is 1/2, the base is 5, the height is 20, or vice versa, whatever you want to do. If I put that in my calculator, I end up getting the area of the triangle is 50. For the area of, this would be a rectangle, it would be 20 times 10, and I would get 200 there. So to get the whole entire area, you're going to add the 50 plus the 200 together, and we get 250 units squared as my answer. Again, because there is no specific unit there, you need to say units squared. So I'd like you guys to try these ones on your own. Again, if you don't know how to do it, that's fine. You can keep playing, but definitely pause the video and try these on your own. So I'm going to draw a line here. If this is 15 here and this is 15 here, that means this is 15 and this is also 15. If the whole thing is 30, if this one's 15, that means this is 15. And then my line here, or my side here and my side here are both 35. So area of the first one, area of the second one. So area 1 is 15 times 15 because it's a square, which would be 225. And again, you don't need to put the units there until the end. For the second area, you're doing length times width or base times height for a rectangle. So you'd have 525. Now to find the area of the entire figure, you're adding area 1 plus area 2. And that would be 750 inches squared. Number 4 is exactly the same as number 2. We're going to draw in a triangle here. You don't know how to find the area of a trapezoid yet, so use a triangle. So I drew that in. If we do not know what this side is here, which would be either the height or the base, whichever one you're trying to find. So I need to use the Pythagorean theorem to do this. So 3 squared plus h squared equals 5 squared. Again, I can subtract the 3 squared from both sides. Put this whole thing in your calculator to find the h squared. Do not just subtract 5 minus 3. H squared would be 16, and then if I take the square root of both sides, I get 4. So my h is 4. Now, if this side is 4 over here, this side also has to be 4. So I can find the area of my triangle, and I can also find the area of my rectangle there. So the area of the triangle is going to be 1/2 base, which is 3, times height, which is 4. Again, you can do that in a different order if you'd like to. It's still going to give you the same answer. Would be 6. And then the area of the rectangle would be 4 times 7, which is 28. You take the two areas, so 6 plus 28, and you add them together, and you get the area is 34 units squared. You do have a homework assignment that goes with this, so make sure to look on Canvas for it. There is an upload section as well for that, and this is due, by the end of the day or over the weekend, whenever you get it done. Have a great day, guys. See you later.